Hey everyone, welcome back. Today, we are asking a question that is on literally every investor and tech enthusiast mind right now. Where are we actually on the AI timeline?
Yeah, and it's not just a general curiosity question. If you look at how we interact with AI, we're in the middle of this massive, quiet shift. We're moving from an era where AI just writes things, writing your emails, writing code, generating images, to an era where AI actually does things.
Exactly. It's the transition from thinking to acting. In the industry, we call this the shift from generative to agentic and physical AI. But as we make that shift, the physical world starts pushing back. The infrastructure underneath is getting squeezed in entirely new ways.
Right. It's easy to get swept up in the sci-fi dream of autonomous digital agents running companies and humanoid robots walking our dogs. But we have to look under the hood. Where are we today, really? What's actual production-ready software versus what's just a glossy demo? And most importantly for our framework, how does this shift change where the scarce resources are?
That's the core of what we call the bottleneck lens. Today, we're breaking down the three distinct stages of AI development, separating the market hype from the hard data, and mapping exactly how the physical constraints of memory, power, and edge compute move as the software evolves. Let's dive in. One small thing up front. We genuinely love these companies as stories, but we're explaining them, not recommending them.
So treat all of this as food for your own thinking, not financial advice. Stay curious, stay a little skeptical, and make your own calls. Welcome to episode 5 of Follow the AI Money. If you're joining us for the first time or just need a quick refresher, over the last 4 episodes, we've built a foundational framework. We've looked at the massive capital expenditure, the memory wall, the electric grid's physical limits, and the hidden packaging and material choke points.
That's right. And before we go any further, let's establish our usual ground rules. This show is strictly for educational purposes. We are not financial advisors, and nothing we discuss here is buy, sell, or hold advice. We don't give price targets, and we don't hold any financial positions in the companies we use as examples. We're here to look at the market through a neutral, consensus-driven lens, tracking the physical supply chains and inputs that stay scarce across the board.
Spot on. So, why does asking what stage are we in matter so much? Because in the bottleneck lens, the answer tells us which specific physical constraint is binding at any given moment.
Exactly. You see, the bottlenecks aren't static. When the industry is focused on training massive new models, one set of components gets squeezed, like ultra-fast networking and specialized GPU clusters. But when the industry shifts to actually running those models in production at massive scale, what we call the inference phase, a completely different set of bottlenecks binds, like high bandwidth memory and power grid capacity.
So by understanding where we are on this developmental arc, we can anticipate which physical inputs are about to become the next hot commodities and which ones might see their demand stabilize. It's all about staying one step ahead of the capital flows.
To map this out, we can look at the industry consensus. Figures like NVIDIA's CEO Jensen Huang, along with comprehensive research from institutions like the Stanford Human-Centered Artificial Intelligence Group, or Stanford HAI, have framed this progression as 3 distinct waves.
Right, starting with the first wave, which dominated from roughly 2023 to 2025, generative AI. This was the era of models that create text, code, or images. It was characterized by a massive, frantic infrastructure build-out as companies bought up every GPU they could find just to train these foundational models.
And now, as we move through 2025 and into 2026, we are entering the second wave, agentic AI. These systems don't just generate text. They perceive, reason, plan, and act autonomously using tools. Here, the economics shift from training to inference at scale. We're talking about AI factories manufacturing billions of tokens. The key metric is no longer just raw flops. It's tokens per watt. It's about how efficiently you can manufacture intelligence.
Exactly. And then looming in the mid to late 2020s is the third wave, physical AI or embodied AI. This is where digital intelligence gets a physical body, whether that's an industrial robot or eventually a humanoid. It's literally taking that thinking brain and letting it act in the messy real world.
And cutting across all of this is on-device or edge AI. Think of AI PCs, next-gen smartphones, and local processors with dedicated neural processing units, or NPUs. For reasons of latency, privacy, and cost, a massive amount of inference is moving to the edge instead of going back to centralized clouds.
Exactly. So we have this beautiful, logical progression. But as we always say on the working thesis, we have to separate the slide decks from the reality on the ground. Let's look at what's actually real right now.
So let's talk about agentic AI. There's so much noise out there about autonomous agents running entire companies. But in 2026, the reality is much more grounded. And honestly, much more interesting.
Right. The deployments that are actually real and in production have a very narrow, specific scope. We're seeing agents succeed in areas like IT operations, customer service, automated coding pipelines, supply chain routing, and finance. Basically, low-regret operational tasks with clear rules and structured data.
It's high-end automation, not sci-fi. Enterprise platforms like Microsoft Copilot Studio, Google Agent Builder, and Amazon Bedrock Agents are leading the charge. They aren't just letting you chat with a model. They're orchestrating multi-agent systems where agents hand off tasks and call APIs.
And under the hood, the connective tissue is still evolving. An open standard called the Model Context Protocol, MCP, got early buzz as a kind of TCP/IP for agents. But in practice, two simpler approaches spread even faster: direct tool calling and skills. Small, composable bundles of instructions and scripts that almost anyone can author and share.
And most teams now blend all three rather than betting on one. Here's what matters for following the money. All that tool and skill activity burns tokens. An agent chaining steps on its own can use 10 to 100 times the tokens of a single chat reply. The market reflects that appetite. Agentic AI is estimated near $9.9 billion in 2026, heading toward roughly $89 billion by 2031, growing more than 40% a year.
It is. And about 78% of the Fortune 500 are expected to deploy some form of agentic system. But there's still a massive gap between a pilot project and full-scale production.
Yes, the pilot to production chasm. This is where hype hits enterprise reality. Surveys show about 80% of new enterprise applications embed some agentic feature. That sounds huge.
But look closer. Only about 23% to 31% of organizations actually have an agent in production. Even more striking, roughly 88% of agent pilots never make it to full-scale production. Almost 9 out of 10 projects are getting stalled.
And it's rarely due to model capability. The real blockers are messy enterprise data infrastructure, complex governance, security concerns, strict reliability requirements, and unclear ROI. If an agent hallucinates even 2% of the time, you can't let it touch live billing or databases.
Exactly. That's why 64% to 87% of these systems are still hybrid, human-in-the-loop setups. The agent does the prep work, but a human must click approve.
It's the safe way. But due to these deployment headaches, Gartner warns that upwards of 40% or more of current agentic projects may be canceled by 2027, driven by governance failures, security risks, or simply failing to prove their economic value.
That's a huge reality check. The inflection is real, but the ROI is highly uneven. If these projects start getting canceled, it could re-rate the entire software layer. Now let's pivot to physical AI. This is where we see those spectacular humanoid videos. But we need to draw a hard line between what's happening in research labs and what is actually real on the factory floor.
Exactly. Real physical AI today is driving economic value in industrial automation. Major manufacturers like ABB, FANUC, KUKA, and Yaskawa run massive fleets of industrial robots on NVIDIA's physical AI stack, using Omniverse for digital twins, Isaac Sim for training robot brains, and Jensen Thor processors for edge inference.
That edge inference is key. These robots sense and act locally in milliseconds to avoid colliding with workers. They can't wait for a signal to travel to a cloud data center and back.
Right. And the technology is moving fast. In 2026, we saw the launch of Cosmos 3, an open omni-model foundation model for physical AI. along with NVIDIA's Isaac GR00T reference humanoid platform. It's an incredible piece of engineering.
It is. But those GRTT reference humanoids are currently shipping to university and corporate research labs in late 2026, not assembly lines at scale. They are still learning.
Exactly. The honest truth is that the first wave of physical AI is boring and industrial. Think advanced machine vision, logistics, and device upgrades, not sci-fi humanoids.
Absolutely. It's practical. But this leads to the heart of our framework. How does this migration across these three stages shift the physical bottlenecks?
This is the ultimate synthesis of our bottleneck lens. Each stage of AI development puts pressure on a completely different part of the physical supply chain.
It really does. Think of the first stage, training. When you're training a model, you run a single, massive workload across thousands of tightly coupled GPUs. That's stressed the raw chip's high bandwidth memory, or HBM, high-speed optical connections, and massive localized power feeds.
But now look at the agentic and inference stage. When you run agents, you are running inference 24/7. In this AI factory model, it's not just about raw compute. It's about HBM memory bandwidth, because the chip has to retrieve model weights for every single token it generates. It also stresses continuous power, CPU coordination, and advanced liquid cooling.
Exactly. The bottleneck shifts from training infrastructure to physical throughput, memory bandwidth, power, and cooling. And then when we look ahead to physical and edge AI, the bottleneck moves out of the data center entirely.
Yes, it moves to the edge. It stresses low-power edge compute silicon, like Qualcomm-class mobile and automotive chips, as well as specialized sensors, actuators, high-resolution cameras, and complex robotics supply chains.
But the golden thread here is that throughout all stages, the constants remain. No matter whether you are training a model, running an agent, or operating a robot, every stage requires more tokens. And more tokens mean you need more memory bandwidth and more megawatts of electricity.
Exactly. That is why power and memory stay scarce across all stages, serving as the ultimate picks and shovels of the entire AI revolution.
Let's look at this through our classic bull and bear lens. If you're a bull on this stage progression, what's the core thesis?
The bull case is that this progression is fundamentally demand compounding. Each stage acts as a massive multiplier for token consumption. A generative chatbot only produces tokens when a human types, but an agentic system runs autonomously in the background, constantly perceiving, planning, and exchanging tokens with other agents. A single human prompt could trigger millions of background tokens.
And physical AI takes that even further. A robot sensing its environment has to process continuous streams of high-resolution video and sensor data, translating that into real-time actions. That is a tsunami of inference. So, token demand grows exponentially, extending the runway for the hardware bottlenecks.
But the bear case is grounded in cold economics. The entire progression is gated by ROI at each step. If agentic AI can't cross that pilot to production chasm, if that 88% pilot failure rate doesn't come down, companies will stop spending.
Exactly. If the software layer can't generate revenue or cut costs to pay for itself, the massive CapEx funding this hardware build-out dries up.
And stage hype can easily front-run stage economics, especially for humanoids. Building a humanoid robot for a warehouse is incredibly expensive. If a simple $20,000 automated gantry system or wheeled cart can do the same job, the humanoid is an economic non-starter, no matter how cool it looks.
So how does all of this feed back into our bottleneck lens? Why is this developmental roadmap so critical?
Because it tells you exactly where to weight your focus right now. Right now, in the transition from generative training to agentic inference, we should be heavily weighting the inputs critical for token throughput at scale: high bandwidth memory, reliable power grids, and advanced data center cooling.
And at the same time, it tells us what is coming next on our watch list. As physical and edge AI mature, the bottleneck will eventually expand to include edge silicon, specialized sensors, and advanced industrial automation hardware. We don't need to bet on those today, but they are firmly on our radar.
This is the beauty of the framework. It stops you from guessing which software startup is going to build the winning agent or which robotics company will design the best humanoid. Instead, you focus on owning the inputs that stay scarce across all of these stages.
Exactly. You don't need to know which agentic framework wins, as long as you know they all run on chips that require massive amounts of memory and power.
And this sets us up perfectly for our next two episodes. In episode 6, we're going to dive deep into the great token shift, how token demand is diversifying and shifting away from central clouds. And in episode 7, we tackle the ultimate question: who actually pays for all of this? And is the application layer finally starting to generate real cash?
What a fascinating journey. We've gone from the early days of generative AI, where we were amazed by chatbots, to the messy reality of 2026 enterprise agents, and all the way to industrial robotics.
It highlights how the AI story isn't just one wave. It's a series of overlapping stages, each with its own economics and physical realities. The shift from thinking to acting is real, but it's hard, slow work.
Exactly. It's a climb, not a leap. And as we've seen, the companies that are winning are the ones supplying the fundamental infrastructure, the memory, power, and cooling that makes every stage possible.
Well said, Maya. Next time on Follow the AI Money, we are digging into the great token shift, how inference is migrating from centralized clouds down to the edge, and what that means for global supply chains. You won't want to miss it.
Thanks for joining us. Subscribe to The Working Thesis, leave us a review, and join the conversation in the comments. Is your company running agents in production, or are you still stuck in the pilot chasm?
We'd love to hear from you. Until next time, keep following the money, keep testing the theses, and we'll see you in episode 6. And that's where we'll leave it for today. Thank you, genuinely, for spending part of your day thinking this through with us.
The whole idea of this show is pretty simple. We hold a handful of theses about the world, and we test them out loud, together, a little more each day. No crystal balls, just curiosity and a willingness to be wrong.
So, if that's your kind of thing, stick around for the next one and tell us where we're getting it wrong. Honestly, the pushback is our favorite part.
Until next time, take care of yourself and keep asking good questions.